these are just the basics, right? We're going to compare it to video games. Right, bear with me. Here is the standard model. Wait, no. Can I have it at a good resolution, please? Give me the fucking standard model. Here's the standard model, right? This is everything that exists, right? And you are mainly this, and this. Okay? And this. Okay. This is reality, right? Reality is made up of this shit. You will never... I will, because I'm clever, but you will never interact with this meaningfully, ever. Right? Or that, definitely not that. Or that. Right? You never even... As far as you're concerned, these things may as well not fucking exist. They're in like a parallel reality to you. As are this. You probably never even come into contact with any of these, right? Maybe a stranger every now and then, right? So these are some quarks that make up particles that are so fucking big that they decay instantly. And the only time you see them are in a particle collider. So they matter to me because I used to do particle physics and analyze boson data, right? And shit like that. But to you, you don't need to know what the fuck these are or why they matter, right? And these are muons, they're like electrons, but you'll also never see them. They'll go through you. And these, right? These are things that pass through you all the time and you don't even fucking notice because they just go straight through you. Right? And you'll never see these because they're so fucking heavy that they don't matter. Right? These matter, but in a way that you'll never experience, right? So they make the weak force happen, right? There's four forces. There's the strong nuclear force, right? There's the weak nuclear force. There's electromagnetism and there's gravity, right? These are the four things that control fucking everything, all movement in the universe, right? And these, wait, the best way to think of it first is for me to talk about the photon, because that's the only one of these that actually you know what it is. Right, photon, that's light. You know light. Well, light is actually the gauge boson, right? The force carrier of electromagnetism. Right, so this thing makes electromagnetism happen. So as basically, if you have some particle, right, and you know it looks like this, it doesn't really, but let's pretend it does, right? And you've got your electron, this is a photon. A photon comes towards it and hits it, right? Then you can actually excite it up to a different level, right? And it jumps up here, boom, and then it spits off another photon, right? And the photon contains the difference in energy between these two levels, okay? So photons, they make electromagnetism work. And in the same way, Z and W bosons, they make the weak nuclear force work, right? And the weak nuclear force is important to radioactive decay. So you know what that is, but you probably don't care about them, right? So they're not really important to you, but that you just trust me, they exist. I found them, right? The gluon's important to you because when you've got an atom, right? So you are, wait, let me just see where I'm on. Okay, right, so here's you. You're like, oh, I know everything's made of atoms. And you might even be like, oh, I know everything's made of protons and neutrons. Hell, you might even know that everything's made of quarks, right? So here's Mr. Proton, and you know, you should remember this, right? That here's a proton, here's a neutron, here's an electron, and it's going around the edge, right? And the electrons balance out the charge of the protons, and that's why they're not ions, right? And these have the same charge. So an electron is a -1 charge, and a proton's +1 charge. How does it get its +1 charge? Because the proton is actually not just a proton, it's a little ball with 3 quarks inside, up, and down, right? And this is down, and up. This is a neutron, right? And then the thing that keeps these shits together is a thing called a gluon, right? And they're the gauge bosons of the strong nuclear force, right? Because if you think about it, right, okay. The reason this thing gets this charge is because this thing has a 2/3 upwards charge, right? And this has a -1/3 downwards charge. So 2/3 plus 2/3 is 4/3, -1/3 is 1. So that's why it's 1 charge. And this is -1/3, -1/3, plus 2/3, that's 0. That's why a neutron's not charged. But if you think about it, this is charged and this is charged, so why don't they push each other away? They don't push each other away because there's this magic shit called gluons that hold them all together. Right, so gluons are the fucking glue of reality and hold fucking everything together, right? They keep everything going. Higgs boson, they just give mass to shit. No one fucking cares about the Higgs boson, apart from some losers in a tunnel. Right, so electron, you know what electron is, right? It's the reason I can communicate with you right now. It's making electromagnetism work. And these are up and down quarks, and they are you. You are this, right? You're these and gluons. And you know what photons are? Photons control everything. Right. So, everything you will meaningfully interact with in the entire... Yeah, maybe. Right. Everything you will meaningfully interact with in the entire fucking universe is made of these fucking things. Right? And this. These 5 things. Right. So, everything from your fucking bread to your, like, I don't know, penis, who cares, right, is made of, like, glue, like, these 5 things. And fucking water and fire and, like, energy. Well, not energy, that's a stupid thing to say. Light and everything you will ever experience. 5 fucking things, right? Which is quite cool, right? Do you know what else is made of relatively small things? Video games. Do you know when you got a tree, you're just like, you know what? Gotta prefab it. And I'm gonna use the same fucking material for everything. I'm gonna use the same fucking units for everything. And why I'm gonna do that? Because then when my GPU passes over the scene, it only has to pass once. When I have 100 objects and they're all the same prefab and they're all using the same material, and my GPU does 1 sweep of the scene. Whereas if I have 100 unique objects, then it has to go and it takes up a shit ton of computing power. Right. So, you know, if you're running a simulation, you want everything to be made of fucking 5 little things. That makes everything a whole lot fucking easier and efficient. But that's not a great argument for the universe being a simulation. But we're just starting, friends. We're just starting. Other things that are interesting. Did you know that the speed of light cannot be broken? Right. And if you try and break it, the universe warps around it, right? So you're walking down the street, la da 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 da, and you're like, doo doo doo, I'm just walking at 3 meters per second, right? Right. You're moving at 3 meters per second. Did you know that the universe is in fucking panic mode when you walk at 3 meters per second? Because you're approaching the speed of light. And you're not supposed to approach the fucking speed of light. Okay, wait. I'll point something out first, right? Say there's a rocket. You got a rocket. No, I don't. Wait, sorry. You got like a fucking helicopter. Or like a fucking... You got a jet. You got a fighter jet, which I can't draw, but that's a fighter jet. Pretend. Right, this is a fighter jet. And the fighter jet fires a missile, right? And it's flying at 500 meters per second. And it fires a missile at 300 meters per second out the front. Would you not agree that the missile is going at 800 meters per second? Because it's got the... Like, same thing as I run with a ball, right? If I run with a ball and I throw the ball and I'm moving 3 meters per second and I throw the ball at 5, then the ball's going 8. Right. So what happens if a plane fires a laser, right? This is going at 500, right? And it fires a laser. Then the laser, which normally goes at the speed of light, c, should go at the speed of light plus 500, right? No, because the speed of light is the speed of light. So the speed of light doesn't give a fuck that you just fired it out of 500 meters per second rocket. Because the speed of light is always the speed of light. So how does the speed of light stop you from doing this? Well, it warps the entire fucking universe to make sure that doesn't happen. So when I walk at 3 meters per second, what's really happening is space is warping around me to make sure that I'm not more walking at the speed of light. Even though I'm going really slow. And we've got this lovely fucking formula, right? That my speed equals 1 over square root 1 minus v squared over c squared, right, is u over that, right. This is my new speed. So this is the speed that I end up going at. Right, this is how reality fucking works, by the way. I don't know if you know this, but the time where I'm at is not the same as time where you're at, and I'm not talking about time zones. I'm talking about if I fly around the Earth in a satellite, then I will age slower than you. If I walk, I age slower than you. If I move, I age slower than you. And we go through time differently, right? So this is v, and what happens is, if my speed is close to the speed of light, so if you imagine this is like, see, right, this is a magic formula, right? This is the speed you actually move at when you think you're going at another speed. Because the speed, you think that the time in one place is the same as time everywhere. It's not. The time in one place the time for you is different from the time for me. And that follows t equals t1 root v squared minus, 1 minus v squared over c squared. Right, that's the time. And the length as well, you stretch. The faster you run, the more you contract. Right, so if you're this big and you run really fast, you actually become like this. It's just the fact is, you never really run very fast, right? You move very fucking slow, right? So we're talking about this thing, this chunk of formula, right? If you imagine it, we got 1 minus v squared over c squared, where c is the fucking speed and v is your speed. Now c squared is fucking 3, 1, 2, 3, 4, 5, 6, 7, 8. That's c. Now square that is 9, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, right? So when you run at 3 meters per second, then this thing becomes 1 minus 1 over 9 kajillion, right? Which I think you will agree, 1 over 9 kajillion is basically equal to 0. Right? You're dividing it by such a large number that it becomes essentially 0. So your number becomes 1 minus 1, right? And I've written the formula wrong. Let's look it up real quick, because let's not be an idiot. Lorentz velocity. No, it is right. 1 minus v squared over c squared. Oh, that's 1 for a start, by the way. No, gamma. Sorry, wait. Gamma equals 1 over that, yeah. Just give me the formula. Ah, this. V plus u, 1 plus v u over c squared. Oh, okay. So it's just time, that's that. The point is, right, this whole thing becomes 0. So the 1 minus 1 over a bajillion. Oh, you know what? I'm an idiot. Right. I thought I'd fucked up there, but I hadn't fucked up. Phew. Right. 1 minus 0 equals 1. Right. So that's that whole thing. This whole thing's 0, right? So this whole thing becomes 1. So v equals u over 1. So basically v equals u, because anything over 1 is just u, right? So there's the maths for why when you move really slow, fucking nothing happens and nothing interesting happens to you. But if you move at like 0.9 times the speed of light, right, then this is going to become 0.81 v squared over c squared, 1 minus that, right, c squared, sorry, 0.1, if you're moving, because 0.9 c, right, squared equals 0.81 c squared, right? So you will therefore move at fucking, if you're moving at 90% of the speed of light, then this cancels with this, by the way, so it's just 0.81, then this whole thing becomes 0.19, right? So you will move at the 5th of the speed. You will move through time at the 5th of the speed you normally move, right? So reality fucks with you. You can think of it like this. This is a graph of you moving, and you are always moving at the speed of light. You're just normally moving at the speed of light through space, right? But when you start moving fast, you start moving here and here and here. Well, in fact, I can do it better like that, okay? Like, you start moving, like, here's you moving. Boom. Now you're moving at the speed of light. And when you're moving at the speed of light, you stop aging. You stop moving through time. And if you're moving, like, half and half, then, like, you'll get, like, root 2 through space and root 2 through time. Right, so basically, the faster you move, the less you age. So if you want to live forever, just go really fast. And if you go off the planet, right, if you and your twin brother, like, if you fly off the planet for, like, 10 years really fast and then come back, then your twin will be dead and everyone you ever knew will be dead because you went so fast. Okay, this is just true. And that's why when you've got satellites and shit like that, they need to control for special relativity because this like, will fuck up your GPS. If you don't control for the fact that your GPS ages different than you, you'll be, like, kilometers out because it's on such small, like, it's on such a small scale. Also, you age slower near a gravitational well. So if you're standing close to, like, the center of Earth or something, then you age slower than if you are, like in space. Anyway, so the point is, oh, and by the way, another thing that happens, if you try and go really fucking fast, your mass will eventually increase, right? And you will get heavier and heavier and heavier because people think of mass as this thing which is like how much shit is in you. And that's kind of true. It's like the density times volume, right? But really, you shouldn't think of it as that. It's your resistance to being pushed, right? Because F equals dp dt, right? And people think of this as F equals ma, right? But it's really F equals dm dA, right? And mass can change too, right? So F equals ma, let's pretend, which is not true. Then your mass is your force over the acceleration. So your mass is your ability to resist acceleration when you get pushed around. So if you're really fucking massive, then it's hard to move you around. But what happens is, if you start to go too fast, you will get more and more massive, so eventually it will be so fucking hard to push you around that you can't push around. And you know what? The universe doesn't want you to go fast. There's this one thing that really doesn't want to be changed, the speed of light, and it's constant. And it will not fucking move. Okay? Do you know what else is constant? Read-only consts. In programming. And also, do you know what else is constant? Like, all of the fucking everything. Like, gravitational constant. Like, fucking Planck's constant. H bar as well. Like, fucking electrical constant. There's one constant that isn't constant, but we won't talk about that. The fine constant. But yeah. So basically, right. The universe is full of all these constants. At the start of their script, right, you got all these constant read-only fucking values that you cannot change and you cannot get around. And so far, these are not great arguments for the universe being a simulation. Oh, however, I do have that one argument that I gave before, was that the universe looks like an asymptotic universe and there's no reason for it to do so, which suggests it could be a simulation. Also, the universe has more matter than antimatter in it. It has 33% more matter than antimatter. Lol, yeah. Right, so if you think about it, matter, right, a proton, if it meets an antiproton, they destroy each other and annihilate it. But our universe exists, which means that something out there made more matter in our universe when it blew into existence out of a ball of energy. It made more matter appear than antimatter, and we've got no fucking clue why this happened. Why was it not an equal amount of matter? How can we exist at all, right? And there's these things called chiral processes, right? And they look like this. Hey. You know what? I'm past the point where Google fucking knows anymore. Like Google Image, I'm past the level of Google Image search, knowing what a chiral process is. This is to do with handedness. Oh, chirality. Look. So you got right-handed and left-handed, right? And our universe is a left-handed universe. Left-handed universe chiral. Right, let's see if we can find anything that's useful for you. Okay. I can't find you a good... We're past the point where Google has any like useful infographics and stuff, because we're past the point where you like, do you know physics is popular in popular culture and stuff like that, and you'll explain the basic shit to people. Like if I explain what was that thing, like if I put like special relativity, then there'll be a nice little infographic for it or something, because like yeah, that thing I was just talking about, right? And the time changing, right? There's all graphics for this. As soon as you get into things like chiral processes, we're at the point where we're out of like the public knowing what the fuck you're on about. So I think you don't need to know, right? But right, so basically there's these magic fucking processes, right, of decay that make it so that there's more matter than antimatter, but not enough. There's not enough of them. We can't figure out why there's more matter than antimatter. There shouldn't be this much fucking matter in the universe. There really shouldn't, and we don't have a fucking clue why. And it kind of implies that there's a creator, but not an Abrahamic creator, because that's fucking ridiculous and just obscene. That's just, God doesn't exist. Right, that's your hint for today. Like, that's your tip. Like, if you're Christian, I'm sorry, I've got something to tell you. God doesn't exist. But the next thing that's interesting. Okay. So I'm giving you all the weak reasons first. I'm giving you all the weak reasons. But these are okay. So these reasons are the anthropic things I was talking about. You got the anthropic principle, right? Which means that hey, I'm on Earth. The conditions that I need to exist. Therefore, it's a miracle, right? But these are like. There are reasons why our universe looks like it's been made, and it's nothing to do with the anthropic principle, which seems to imply creation. Yeah. We're just getting started, fam. Okay. And you could talk about how the universe or the dimensions are an n-dimensional manifold. Right. Let's talk about the real shit. Let's skip over the other small things about. Okay, I'm explaining why the universe could be that. Okay, this is why the universe is a simulation. This is a quantum well. Welcome to quantum physics, where everything fucks up. Okay. This is a particle, and it has enough energy to get to here, right? Can only get to here. You can think of it as like a ball on a roller coaster, right? And it starts as like a cart on a roller coaster, in fact, and it goes up and down and up and down, and except like there's no friction, so it doesn't like whereas this thing will eventually slow down and stop, right? This thing could just keep going up and down, right? But it doesn't. Gets out of the fucking well. Boom. Right? It doesn't have enough energy to get out of the well. It's impossible, right? It does not have enough energy to get out of that, and yet it quantum tunnels, right? It just goes through. And you've got this thing called Heisenberg's uncertainty principle, right? And Heisenberg's uncertainty principle says that if you know the position of something and its velocity, well, you just can't, right? You can't know the fucking position and the velocity of something. It's impossible. As soon as you know the position of something really close, the velocity becomes super fucking huge, right? And as soon as you know the velocity really close, the position becomes huge. So if you know something's exact velocity, then you cannot know its position. And if you know something's exact position, its velocity becomes fucking tremendously large, right? So basically, if you take this thing and put it in a really small box, right, and it doesn't have enough energy to get out, essentially because you look at it so hard, it clips through. And they can't explain that shit, but it clips. It's the exact same thing as if you're in Unity, right? And you've got a discrete fucking rigid body, and you've got a wall here, and the wall's this big, and there's no way for this object to get through the wall, but it happens to be going at 300 fucking meters per second, per step, let's say, rather. It's going 300 fucking meters every step, and one step happens to be here, and it just steps. It doesn't give a fuck that it just went through something, because it doesn't even realize that it went through something, because it's discrete. Okay? This is exactly what fucking happens all the time in the universe. All particles constantly just fucking step through shit, which should be fucking impossible. The next thing that's interesting is in more on quantum physics. So clipping exists. Clipping is a real life thing in real life. It's a glitch in games, it's a glitch in all programming, but it's a normal feature of real life. The other thing that's interesting is particle wave duality, right? So particles carry everything that a wave. Okay, do you know what's a particle and a wave? An MP3 file that contains all the properties of a particle and a wave. Do you know what else does? All fucking electrons and everything. Right. So you fire an electron through here, right? Then on the wall. Okay. This is a slit, right? This is a slit. Okay. And this is the wall behind it. And if I fire snooker balls through the slit, then they will go like this. Dunk, 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 dunk. And they'll hit, like, all up and down this line. They'll make a line here. But if I fired, like, water through this hole, or, like, air or a gas or something, then the gas would spread out like this, right? Like, or water or something. Like, or a beam, light, right? If I fire a laser, then the laser will be strongest here, and it'll be a spectrum, and it'll fade out, and it'll still be here, but like faded out, right? So everything that goes through this slit ends up on the screen. If it's a particle, then it'll just hit the screen in the middle. If it's a wave, then it distributes along the screen, right? But if we have an electron, right? And we put two slits down, right? The double slit experiment. It's a very fucking important thing that one Monsieur Einstein did, right? And Schrödinger. Schrödinger really didn't fucking like this one. That's why he invented his cat, right? So you fire this shit through, right? And you'd expect, right, if you fire balls through these two things, you get one line here and one line here. And if you fired waves through, you get the most waves here and the most waves here. And then this bit in the middle would also be strong, and then not much here. Because the particles that go through, if you look at this diagram, right, the particles that go through here, these spread out here, and these spread out here. And these cancel each other, right? But then they start here again. So you actually get like a spectrum, like you're gonna get like a weird pattern. But when you fire an electron through, instead what happens is the electron goes through, and you'd expect it's a particle, right? So you expect it to only be in one place, but instead it's fucking everywhere, right? And so you're like, oh, well, that must mean that they're bumping into each other and shit. But no, if you fire one electron through a hole, just one single one, and then do another one in 5 hours' time and add them all up, then you get this exact thing. And not only this, but they go through the thing, right? The particle, it goes through both holes at once and joins up. Like, it goes through this slit and it goes through this slit, and then it hits the wall, right? And it also doesn't. It simultaneously hits the wall, goes through both slits at once, goes through the right slit, and goes through the left slit. All 4 of those things happen, and they just do, and we can prove it. All 4 things happen, right? It's really fucking weird. And then you can write that as like some function, right? So you got this wave function equals like, and then you'll have like, oh, phi1, phi2 plus like c1, c2, and then like you integrate this whole shit, and like you got like, you basically got this wave function, right? And this wave function is essentially made up of all the probabilities of all the different things that can happen. So this probability of slit 1 and slit 2 and both the slits and neither of the slits, right? And it's got like you get a nice Hamiltonian out of this, right? Let me show you a Hamiltonian. Yeah, like this, right? So you get all the functions of this, all the properties of it, right? So that's like, okay, it's fucking weird, but whatever, right? Universe is weird, except you can entangle particles together, right? Oh, and also, sorry, when you observe it here, right? When you set up the slit and you look here at slit 1, right? You set up apparatus to measure it here, then all the particles go through slit 1. Right? And if you set up your apparatus here, all the particles go through slit 2. It doesn't give a fuck. As soon as you observe it, it starts going at the location that you observed it at, right? And you basically just distort reality just by looking at it. As soon as you look at it here, then it is here. As soon as you look at it here, then it is here. You collapse the wave function by looking at it in exactly the same way that you look at it, right? So the spin, particles have this thing called spin that's not really spin, but it can be up or down, right? And you can entangle 2 things with each other. So you can get one particle, get another particle, take them in a room massively far away from each other on the other end of the universe, and they will break the speed of light, because as soon as you spin this one up, this one instantly spins down. You can measure it and see. This is called spooky action at a distance. These things communicate with each other fucking instantly. Okay. So, these 2 things, like, by looking at something, you affect something that used to be a probability, right? And you make it into a reality just by looking at it. And then as soon as you observe it once, it will always be that. As soon as you observe, right, if something has a spin of positive or something, or negative, you can predict the probability. You can say, hey, there's a 33% chance this is going to be up or something. You can predict it, but you never know, and you never will know, and you can't ever be 100% sure of anything. You can only predict the probability of it happening. But once you've observed it once, it will always be in that spin forever. If you observe it again and again and again and again and again, it will always be spin up, right? Do you know what this sounds like? It sounds like a motherfucking function. It sounds like a class constructor. You get your class constructor, and it has some values, and they're randomly determined, and then as soon as you access this class, then this thing, which was previously like plus or whatever, like it was previously a random thing, now forever this thing has a true value that's already been assigned. You assign a value to it. And so that explains that when you observe something, right? Why the fuck does it matter when you observe it? Why would that change things? Where you position the camera changes reality. As far as I'm concerned, when you observe something, you observe its class constructor, right? You're looking at its class constructor and accessing it, and then as soon as you've accessed the class has a value assigned to it, and now it no longer fucking... It's no longer random. You eliminate the randomness. So... And we don't... Without simulation theory, there's no fucking reason why any of this would happen. It doesn't make any fucking sense why when you get small enough, shit just breaks. But, I mean, and there's another thing, is that everything, if you look at an atom or something, the reason I can't put my hand through my other hand, people think it's because of repulsion. Well, some people don't think about fucking anything, right? Let's be honest. Some people think that it's because the electrons in my hand are repelling my other electrons, and that's total bullshit. I mean, it's true to some tiny extent, but that's how I can feel, right? I feel because of electromagnetism. But what's really happening is, right, you got this electron, and it can... I should actually draw real orbitals, right? So you got an s orbital, and then you got a p orbital, right? And you got another p orbital. Right, there's these orbitals, right? So you learn in like GCSE physics 2A888, which is bollocks, right? It goes 1p2, 2s2, wait, 2... No. 1s2, 2s2, 2p6... What? Wait. 3s2, 3p6, 4d10, 3d. Wait. No. 4s2, 3d10. Yeah, this is I did physics at uni, so that's why. Oh, well, like, this simulation stuff isn't taught. This is just me saying that there's no fucking way there's no fucking way it's not a simulation given all of this stuff. Right. So these are the orbitals, right? Right. Your electrons can only hang out in areas they like, right? So you got, this is S2, right? And this is a p orbital, and a p orbital has 6 in it, right? And they can only occupy like this, right? They go up, and then they go down, right? And this is getting complicated to explain because we'd have to talk about quantum numbers. Okay, let's just talk about it in really basic terms, right? If you have, like, an orbital, and you want to jump from a 2 shell to a p shell, right? Which you can. Right, this electron can jump from here to here, it's possible. But the only way of doing it is it's got to have enough energy. So if you have a fucking electron... Boom, a photon, right? And this comes in and gives this energy, right? If it doesn't have enough energy, in fact, we'll just do circles because you don't need to know about chemistry, right? If you've got one circle and then you got a second circle, right? This can jump to here. This is the next shell up, right? But if it only has 0.5% of the energy, like 50% of the energy to jump up, it will stay halfway up. No, it won't. It won't stay halfway up. It can't go up. Like, the electron will come, and it will just go, fuck you, electron, and it'll send it back off, right? But if it gets 1.2 times the energy it needs, then the electron comes in, this basically fucking eats it, reappears here with way more fucking energy, and then spits the electron out with the 0.2 that it had left. It only took the exact 1, right? And it's called quantized, right? So everything is fucking h bar over 2, right? Everything is works in Planck constant versions of energy. You've got all these like h bars, right? You cannot have electron cannot be halfway between two things. It's in an array basically. You have like a computer array, and it can be here, and it can be here, and it has to have sufficient energy to be in either one, but it can't be in between. And that's why when my hand pushes against my other hand, right, then the electrons can't go through each other, because this one, like, these things can't overlap each other. They have specific discrete space. The universe is fucking discrete. And it has a minimum time, right, which is fucking Planck time. Right, it's like 10 to the minus 34 is one step. Right, the universe works on time steps, and it works on distance steps as well, 10 to the minus 34, right? These are the steps of the universe. And it works on energy steps. Everything's just steps. Everything in the universe is fucking discrete. It's discrete particles that stay in specific set arrays and only stay in them. There's nothing continuous. Time is on time steps. There's a maximum fucking time. There's maximum values to everything. There's a maximum energy. There's a minimum energy. There's constants. Things clip through each other. Things get accessed and become random, random until accessed and then don't become random anymore. The things possess all the properties of a particle and a wave at the same time, which is perfectly fine in computer theory. And the universe seems to require a creator. Also, I think the most convincing argument for the universe being a simulation is that we probably, right, there's a good we expect more life out there. We expect there to be a lot more life out there. We're not special. There's lots of life, right? And if life gets intelligent, then clearly life wants to run simulations, because we do. Life wants to figure shit out and create order and defy entropy. And so if we manage to create a simulation, which we've done on the 10 to the minus 15 scale so far, our femtoscale, right, we've run perfect simulations on femtoscale, but if we could run a full-size universe simulation, right, on a lower time step, or a smaller universe or something like that, right, then we could simulate a universe, and we'd probably not just simulate one. We'd have, here's our box, here's another box, here's another box. Once it becomes easy to do, once our computers become big enough, we can simulate fuck tons of universes at the same time. And why wouldn't we? We'd be simulating all the fucking time if we could, right? And then in each one of these simulations, they are therefore then a simulation, right? And then this simulation is therefore likely to have life inside it, and as long as the probability of life occurring times by times by the number of simulations is greater than 1. So if you imagine it like if the universe had one simulation in it and always 100% of the time evolve life, then we would have this trick. We'd have a line of a universe, and this would simulate a universe, and this would simulate a universe, because they all run on the same rules, right? So the probability of something is 100%, then therefore every single simulation would have a simulation inside it, and every single simulation would have a simulation inside it. But I think instead we've got a non-100% probability that life appears in a universe, but it's probably greater than 50% chance of life evolving in a universe, sentient life, right? But I got, that's just guesswork, right? You can't know what the number is. But if that number multiplied by the number of simulations that we make is greater than 1, then that will mean that on average every single universe will have a positive number of universes inside it, right? So say we simulate 10 and we had a 50% chance of having it, then on average each universe has 5 simulations or something. But I think probably the number's like hundreds. So if you take one universe and then inside it there's loads of fucking universes inside it, right? And then in each one of them there's loads of fucking universes, just using probability theory, then the fact is all of these universes are fucking, like, none of these are the top universe, right? Because it becomes an infinite chain, basically, of universes, or at least so large that it's crazy to think you'd be at the top. So then the probability of you being at the top of that universe is 1 over some very fucking large number, right? So basically infinity. So basically the probability of you being the top universe is 0. So as soon as we run a simulation that's successful, we basically instantly know that we're in a simulation, because if we weren't in a simulation, how would we simulate our universe? And if it's probability likely? And especially if someone in our universe starts simulating, then we know for sure that we're in a simulation. Because otherwise, you're talking about a 0% probability, essentially, of us being at the top of the chain. So, like, we are almost fucking certainly in a simulation. Like, yeah, we will, we'll end up making a simulation to find out how to break out of our simulation. Yeah, there has to be a top universe, but the probability of you being at the top of the universe is fucking so small it's not even worth considering. And maybe like halfway through, this universe looks like The Simpsons, you know, and then decide to make us. Right. Maybe they like fuck around with our universe a bit, and the universe above us isn't quite like ours and shit like that. No, because you can simulate it on a lower scale or a lower time step. So it's fine. Or you can simplify the rules. There's loads of ways you can simulate. Oh, and the orbital stuff. Yeah, orbital stuff is high school.